The lesson for today is relation and a function. Relation and a function are the most important topic in algebra. Any type of algebra, whether it's algebra 1, 2, or higher level algebra. There are two different words having different meaning in math. They're the same, but they have a different meaning. So what is the different meaning? Relation will show the relationship between input and output, where the input is the x value and the output is the y value. But a function is a relation which derives one output for each input. So every x value will associate only one y value. If one x value associates two different values, then we will consider that it's not a function. It might be a relation, but it's not a function. So now let's differentiate between relation and a function. Relation can be displayed in four different ways: in order pair, table, mapping, or a graph. So let's look for the order pair. As you can see, the order pair, it has a two different value. Value number 1, value number 2. So those two values are considered, the first number is the x value, the second number is the y value. As you can see, these two order pair has the same x value, but it's two different y value. And then everything else is the x is a different number and y is a different number. Even though these two x value have two different value, this is a relation, but it's not a function. But we will consider function later on, but as of now, we know this is a relation because -2 will associate 1 and -2 will associate 1. So this will be displaying in order pair for a relation. So how do we display in a table? We can display in a table as a horizontal way, or we can display in a vertical way. Either will be the same. Always you will have x and y. So the x values are the green one and the y values are the red one. So if you can see that -2 associate to 1 and -2 associate to 3 the same way. We're just representing the order pair in a table. It might be the same values, but a different value, but it's the same display. So now let's look the other two display. So the third one that you can display in a relation by mapping the x value into y. As you can see, we will map -2 into two different 1 and 3, whereas 0, 1, and 2, each one will map a different number. So the last one is relation in a graph. As you can see, the x value is 3, whereas the y value is 1. When x value is a 1, and then y value will be 4, so that's why we have a dot. But when we have a -2, we have 1 time associated or paired with a 1 and 1 time with a 3. All are relation, because we only consider relation from x to y. So let's look for the function. A function is a kind of relation, but because it follows an extra rule that the relation does not follow. So a function similar to a relation, it has a set of order pair. However, the order pair for every x value must be associated only one y value. If one x value associated more than one value of y, then we will consider that it's not a function. So let's look one order pair that is a function and is not a function. As you can see, the x is a unique value, but we see x equal to -2 and then another x equal to -2. So the second question that we ask, does the -2 associated to one value? We can see this one associated to 1, but this one is associated to different number. That's why this relation is not a function. Because it says every x value must be associated only one y value. So let's look at the one that represents a function, a relation that represents a function. As you can see, all the x values are unique. There is no duplicate x value, which indicate every outcome of the y could be the same. The -2 could be 1, 0 could be 1, 1 could be 1, and so on. If all the y values are the same number, then that still is a function. The only thing that cannot have every input, which is the x value, must be associated on one and only one output. But multiple different way input could have the same output. Then that still is a function. The only thing that we have to look for the input or the x value. So knowing that, let's see these examples. So how do we determine whether a relation is a function or not? Then we will explain. Always we will look for the x value. As you can see, the x value is a unique number. There is no duplicate because -6, it only appears one time. -2, 1, and 3 all appear in one time. They all associated different value for y, or they could be associated the same value. They could all be 4, or all will be 1, all will be -3 or -5. So we will say, yes, this is a function because every x value is associated one and only one y value. That is the explanation. So what about number 2? We can see the x value is a unique because 4, 6, and 7 are only one time. But the 4 will associate to 2 different outputs. One time the output will be 2 and the second output will be 5. So that will violate the function because the function indicates every input must have one and only one output. So this is not a function, but it's a relation. This is a relation and it's a function, but this is a relation, but it's not a function. Now we have a table and we have a mapping. So now let's do 2 different tables. We have to look, before we even start looking whether it's a relation, it's a function or not, we have to look for the x value. As you can see, the x value, there is no duplicate because the 4, -1, 0, 1, and 9 appear only once. Once we realize that, then we will assume the relation is a function. Why? Because the 4 associate only one value and -1 different value, 0, all of them associate with one and only one output. So this will be a function. So what about on 4? As you can see, the x we can see is 2, 5, 3, -4, and 5. We could see we have x value duplicate or 2 different places. And then we will look what is the outcome. Sometimes you can write 5, the same number, another 5, the same number, which indicate the same answer. But as you can see, there's 5 associated by -3, and then the input of 5 associated with 2, which indicate one output cannot have 2 different outputs, so this one is not a function. So now we did the table and we did the mapping. So now let's do the different way of representing a relation, a function, or whether a relation is a function or not. Now let's do the ordered pair. We have to look for the x. X will be -2, 4, 3, 5, and -2. As you can see, there is no duplicate for x, so then we will say this relation, yes, is a function because every x value is associated one and only one output. So now let's look on number 6. So you can see we have a 6 for input or x, or we have -4, we have a 5, then we have a 4, but now we have a 6. We can see the 6 is associated or is paired with -1, and then this 6 is paired with 5. So this one is not a function because one input is associated 2 different outputs, so this one is not function. This relation is not a function. So now we know how to do for an ordered pair, table, or mapping. So how do we do when we have a graph with no input, output, or any other values shown? So now that's when we need to learn a new concept. The new concept is we will use a vertical line. We will draw a vertical line similar to the Y and then see if the vertical line crosses the graph, any type of graph, more than once. If that happens, then we will consider that it's not a function. So now let's do the first line. The vertical line goes through this, and then you can see we're only touching it one value. That could have X and Y. So let's do a different location. So you can see we're only touching the graph once. So every vertical line that we draw into this graph will only touch one and only one place for the graph. So what about the second graph? So you can see once I draw the vertical line, I'm touching it, the graph on this location, then I'm touching another location, which indicate this value has two different outputs. I want you to know that the input will be the X value, the output will be Y value. So now if you can see if the input is a 1, the output is 1, and the output is a -1. So this is not a function, and then that is a function. So if you have an ordered pair, just look for the X value. If the X is not duplicate, then that's a function. If the X's appears to different location or more than once, then it's not a function. But what about the mapping? You will only look if the arrow from the X value goes into more than one location. What about a graphing? You just use a vertical line, drawing a vertical line into the graph. Whatever the graph is, this is a linear, this is a quadratic, so you just grab the function and see if you're crossing it once. For the graph, then that one will be a function. If it crosses more than one, it's not a function. Knowing that, let's do this rule. So how do we write a function rule from a table, a graph, or a map? So step number 1, we will compare the value of each. Let's do this one. So now we know when the input is 1, the X is 9. That will tell us when the X value is 1, Y will be a 1. And then the second order pair, when X is 2, Y will be 10. So we know that each time X will be increased by 8. So 1 plus 8 will be 9. 2 plus 8 will be 10. 3 plus 8 will be 11. And 4 plus 8 will be 12. That will indicate each X value will increase by Y. So we write the function rule for this table as Y will be equal to, when the X value is given, we will increase by 8. So you can test any number. If it's a 3, then 3 plus 8 is 11. When it's a 9, 9 plus 8. So this rule of function will create this table. So what about the second one? So let's do one order pair and then the second order pair. If you can see, the first order pair is 3 and 12. We can see that it did increase by 9. Let's look for the second one. 5 to 20. We can see that it did increase by 15, which indicate it's not a linear because it's not increasing in the same number. Because this one will increase by 9 and then this will increase by 15. Which indicate every time that we have the X, then we multiply him by what? By 4. If you can see that 4 times 3 will be 12, 4 times 9 will be 36, 4 times 5 will be 20, and 4 times 7 will be 28. So the function rule that created this table is y will be equal to 4 times whatever the x value is. So you can pick up any number. You can say 11. 4 times 11 will be 44. All this value for the input using this function rule will create this output. So now in this, let's review in different concepts. Here are some of the types of the function that you will encounter in Algebra 1. A linear function. A linear function is y equal to mx plus b, where the equation with variable but there is no exponent. If you see the exponent is 1, so an example will be y equal to 2x minus 5. Quadratic function is, the general form is this. And you can see that the description equation with a square term, because we will have x power 2. This one does not have any power. Then the example is f of x, x power 2 minus 6x plus 7. What about the exponential? Exponential function is an equation with variable as an exponent. If you can see that the numerator 2 is any number, and the exponent of the power is a variable which is x. For example, f of x will be equal to 2 power x. What about a rational function? A rational function is an equation with a variable in the denominator. So you can see that we have a variable in the denominator as x. So to write an example is f of x will be equal to 3x plus 1 divided by 2x plus 3. We can see that we have a variable in the denominator, which indicate the denominator cannot be a 0. Any number that is not 0 will satisfy this equation.